Le monde moderne ne repose pas sur la magie, mais sur des systèmes physiques. Des câbles sous-marins aux agents autonomes, notre quotidien dépend de couches invisibles. Bienvenue sur ma chaîne. Fasciné par les capacités exponentielles de l'IA, je consacre ce canal à décortiquer ce qui se cache sous l'interface.
Bienvenue à bord.
Welcome back to The Explainer. Today, we're doing something a little different. We are completely stripping away the generative AI hype to audit a critical, frankly massive, infrastructure vulnerability. We're facing a harsh reality here. The everyday software tools we actually use to measure and evaluate AI are, in a lot of cases, fundamentally broken. If you've been building or deploying language models lately, this is absolutely the operational bottleneck you've hit, even if you couldn't quite put a name to it. So let's kick this off with a bit of a skeptical inquiry. Picture this. You've built a really powerful hybrid AI agent. You're testing it locally, and hey, it seems to perform brilliantly. But if your chief information security officer looks you dead in the eye and asks for programmatic proof that your system won't hallucinate a financial figure or, say, a medical dosage once it's in production, what exactly do you say? Can you actually provide objective proof, or are you just sort of relying on a vibes check and crossing your fingers? Because in enterprise deployments, guessing is a guaranteed recipe for failure. Okay, here's our roadmap for the explainer today. 1. The end of LGTM development. 2. Evaluation infrastructure collapse. 3. The anatomy of harness failures. 4. The memory trace trap. 5. Strict LLM CI/CD. And finally, 6. The code agency era. All right, let's jump straight into part 1, the end of LGTM development. We are officially seeing the absolute end of looks good to me, or LGTM-driven development. Up until recently, building AI was basically defined by tweaking a prompt, chatting with the bot a few times, deciding, yeah, looks good to me, and just shipping it. We have to completely abandon that approach. We've got to shift to a rigorous, automated engineering discipline, where your code is objectively measured against a golden dataset. I mean, think about it. When you deploy to hundreds of thousands of users, a single regression hits thousands of people instantly. You literally can't just eyeball that kind of scale. There's a quote that sums this up perfectly. AI without measurement is a car without a steering wheel. Deploying AI without a continuous, automated evaluation pipeline in place is literally flying blind. Sure, you might have this incredibly powerful engine, but you have absolutely zero control over where it's going or, when it's going to crash. Which brings us to part 2, the actual collapse of our evaluation infrastructure. Now here's where the problem really compounds, and frankly, where it gets pretty alarming. The very software harnesses we rely on to evaluate these models, they're collapsing under the weight of their own complexity. Recently, researchers conducted an empirical study where they decided to look at machine learning evaluation harnesses not as abstract math, but as actual deployable software products. They systematically studied 57 different evaluation harnesses that are currently out in the wild. And we're talking about the exact tools that underpin almost every major AI benchmark leaderboard out there right now. And the results? Well, they were absolutely staggering. They mined and analyzed exactly 16,560 developer-reported GitHub issues from these 57 harnesses. The data reveals a systemic facade of competence. Basically, the underlying infrastructure we use to grade AI is suffering from severe foundational software engineering debt. So, what's actually breaking? Let's unpack that in part 3, the anatomy of harness failures. When you look at the breakdown of these thousands of failure reports, a really surprising pattern emerges. You'd probably assume these tools are failing because the AI math is just too cutting edge or complex, right? Well, actually, no. A massive 61.7% of the failures are just incredibly basic software engineering gaps. We are talking about unimplemented features at 24.3%, poor documentation confusing users at 20.3%, and absolutely critically, silent validation failures sitting at 17.2%. And guys, it gets worse when you zoom in on the assessment stage, which is the exact moment the tool is actually supposed to score the AI. Over 48% of the issues right here are algorithmic errors or validation gaps. That means the harness might silently compute the completely wrong score because of a math bug, or it might accept the wrong data format without throwing any runtime error at all. It just spits out a highly plausible, entirely incorrect grade, and developers are just blindly trusting it. Okay, moving on to part 4, the memory trace trap. This whole infrastructure collapse turns into a literal trap when we start dealing with more complex, stateful LLM memory systems. To really understand this trap, we first have to define something called verification asymmetry. This is basically the structural reality that validating a solution is fundamentally easier than generating one from scratch. For AI to actually advance reliably, we need infrastructure that can verify the wildly complex states these agents generate over long, multi-step horizons. Because simply put, if we can't verify it, we can't trust it. Think about how this plays out in the real world. Failures in stateful memory agents are rarely immediate. An error might overwrite a stored user preference really early in a session, but that tiny mistake might only actually manifest hours later. By the time the retrieval finally fails on that corrupted state, your execution log could easily exceed 10 million tokens. And at that massive scale, doing a manual human audit to find the root cause isn't just annoying, it is mathematically impossible. You absolutely have to have automated tracing. So, what's the operational consequence of all this? That brings us to part 5, strict LLM CI/CD. Since manual human audits are impossible and our basic evaluation tools are proving to be fragile, we are forced into the absolute necessity of strict LLM continuous integration and continuous deployment. We have to architect rigid automated deployment gates. When a developer pushes a prompt or a code change, Layer 0 smoke tests must validate basic structures in under 2 minutes. Then, Layer 1 runs deterministic comparisons against your golden dataset in under 10 minutes. And finally, Layer 2 brings in an LLM as a judge to score semantic quality, taking about 30 minutes. If any single metric drops, the deployment is blocked programmatically. No exceptions, no overrides. What this pipeline does is dictate a very strict allocation of your resources. We do not waste human time on things that machines can check. Deterministic APIs, data groundedness, exact financial figures, all of that is strictly automated. But subjective edge cases, tone, brand voice, and genuine human helpfulness, those are routed directly to human subject matter experts. And here's the payoff. When your evaluation harness is properly calibrated, and by that, I mean it's a heavily engineered, finely tuned setup built against a bulletproof golden dataset, not just some out-of-the-box fix, only about 5 to 10% of flagged interactions should actually require that human review. You end up automating the vast majority of your LMOOps feedback loop. It saves a ton of time and completely eliminates all that LGTM guesswork. Which finally brings us to the solution space. Part 6, the code agency era. To build genuinely reliable systems, we're moving into what's being called the code agency era. We absolutely have to shift away from language model agency. That's where you let the LLM unpredictably orchestrate tools and just kind of pray it figures out the logic on the fly. No way. Instead, we must move to code agency. In this new model, a strict, measurable, deterministic code base acts as the controller that orchestrates the tools. The LLM, it's restricted to simply handling the human-computer interaction layer. This architectural shift unlocks a continuous, closed-loop system. We observe production traces, we evaluate those specific spans right against our golden dataset, we identify algorithmic failures programmatically, and then we deploy fixes only when our strict CI/CD gates prove the fix actually works without breaking something else. Ultimately, you need a robust scaffolding. Your evaluation harness isn't just a nice-to-have dashboard you check once a week. It is the strict infrastructure that ensures you aren't relying on an LLM just randomly guessing how to improve its own code, what developers jokingly call vibe coding. A true evaluation engineering pipeline dictates exactly what is broken and gives you hard proof when it is fixed. So, I want to leave you with this one final highly practical question. If your underlying evaluation infrastructure is collapsing and you cannot objectively, programmatically prove your AI works against a golden dataset, should you really be deploying it to your users at all? It is definitely time we start treating AI evaluation as the rigorous engineering discipline it actually is. Thanks for joining me on this explainer. I'll see you in the next one.